Hi folks, welcome to my Bit Retro Journal. I'm continuing celebrating the Macintosh in the month of March by participating in Macintosh. The first two videos I actually did on my first two products, which was Climate, which you see down here, and then Cron Manager, which is you can see up here in this package. These are packages of Japanese products. You can see here that if you look closely, that the writing is Japanese. So I had a Japanese distributor that packaged my products and sold them in Japan. And so so this is the one I did, the product I did last week. And you can see that it's obviously in Japanese, but it's sold for 4,500 yen in the 90s, early to mid 90s. And the graphics artwork wasn't great, but the reason they had they had distributors is because the Mac actually lent itself pretty well to localization, because you could just go in the resource fork and change things, and so that's why the particular reseller contacted me and said, "Hey, we want to sell your products." And what actually caused both of these products to be put on sale was this product. So this was this was the only product I've ever done two versions of, and you can see that the original version, this was actually the original version. Version 1.0 of CPU double, and this is what I'm going to talk about today. They wanted a version 2, and so they actually told me what they thought would be better, and so version 2 was created, and this was version 2. Had a more modern Mac look to it. I noticed that it had a sliding bar here as opposed to discrete ones. You could still customize it. There was the button here was actually a way to get information on the system and how fast it was actually optimizing your system. So that's one thing you really wanted, and the customers wanted. And so the second version sold successfully again, and you can see some windows here that show you the thing running. Here it shows you what this additional feature that told you how much faster your computer was running was. So yeah, so these were these products never were packaged in the US, and the reason why it has to do with a company called SoftRAM. So when I created it first, I actually discovered another product that I really fell in love with, which was Connectix RAM Doubler. And when I first heard about it at my work, we used Macs there. We purchased it, and it gave you, if you had 4 megabytes at the time, memory was very expensive, you got 8 megabytes, and I thought it was like, that was genius. And then I sort of did a little bit of digging to figure out how it worked, and it was even more genius when you figured out how they actually did it. And I remember thinking, if I could only be as ingenious as those folks were. And after the fact, I actually realized that I had done the same thing they had done with memory, i.e. space, I actually had done with time. So CPU doubler and RAM doubler are actually very synonymous, and they could work together, but one compressed space and the other one compressed CPU cycles in some way. Well, again, it not really compressed it, but they compressed usage of it for certain processes. So in essence, compressing time. And so CPU double ended up actually doing very similar to what RAM double did for memory, it did for the CPU. And I'll go over that. But the reason this was never a big product in the US is because by the time this came out, later than RAM doubler, another company, SoftRAM, had already sold its ware for the Windows environment. And if you can watch the Nostalgia Nerd, he did a piece on SoftRAM. They basically lied to their audience. The Windows was complicated enough to where they could just say, "Oh, you have more memory, you got twice as much," but in reality, they didn't do anything, and people discovered it as they sort of analyzed it, and then SoftRAM got into a lot of trouble. And so resellers, especially for a product like CPU doubler, were like, that's impossible. that seems like another scam, and so they were hesitant to take it because they felt like the public might not buy it. Interestingly enough, had I named it something different, had I named it, and I did have a shareware version eventually after this was sort of done selling, called CPU Charger, because obviously this didn't double the number of processors you had on there, even though the icon demonstrates that it does, right? So it was a cool name, but what it really did is it optimized the processor. So it was a CPU optimizer, or a CPU Charger might have been better than doubler. But that's sometimes best intentions sort of go by the wayside, because again I loved RAM doubler. I thought, hey, see, that's kind of doing something similar, and when I analyzed it, I realized I was doing actually something very similar in terms of, not, again, they had completely different technology that they utilized, but the idea was the same. Even though I had already been working on this before I saw RAM doubler, it was nice to realize that I was doing something similar. And it was, again, kind of all spawned by what the QL was doing, which I'll show you first what the QL does. Then I'll explain to you how CPU doubler works and how it kind of matches the RAM doubler. And then I'll show you on the computer, on, again, the emulator, how it works. But in any case, so that's what I'm going to do today for Macintosh CPU doubler, my most successful program I've written. It was up for an award in '96, I think, in Japan, for product of the year. They didn't win it, but in some category, and it was like the #3 bestseller at one point in the Japanese market. Again, the Japanese market was different from the US market. They tended to keep their machines, so they needed software that helped them optimize the usage when they slowed down. All right, so let me first show you what the QL can do, which mimics it, and then I'll come back and clear this out, and kind of piece of paper I'll show you. I'll sort of draw up what CPU doubler did and how it did with RAM doubler. All right, here we go. All right, so I'm on the QL, and I'm in the command shell equivalent, mode 8, so you get more colors. So the bare QL doesn't actually have the jobs command, so I need to load in. So it's some MDV 7 boot, and what that is going to do is load in a RAM version of the Toolkit II. You can get that as part of a ROM cartridge or various accelerator cards. And so this is going to load in, and you'll see that on the bottom it'll say Toolkit 2. Oh, it did not say that. Oh, because I loaded it and run it. So you can see that it says it's about 70,396 bytes. If I run this, it's going to load in the Toolkit TK2 bin file, and that's going to give me, as I said in a previous video, the Toolkit 2 did not come with the original QL. It came out a year later. But now we have a jobs command. So I'm going to execute MDV8 is the cron. That's the little program I wrote for when I was going over Cron Manager. And you'll see that it's going to run this in the background, and it's going to beep every 10 seconds. It's going to actually put it into the high resolution mode, which is less color. So I'm going to put this so the jobs running now. You can see it's called, I never renamed it, so it's Digital C. But let me put it back into mode 8 mode, and you can still see jobs. If I look at the job, I can actually set the priority of a job by giving it the job and tag number, and then a new priority. So for instance, I can give it 0, and now you'll notice that the job has actually stopped running. It's still there, it's still active. ICE doesn't actually run that much faster. It's still there, but you'll notice that there's no longer a beep showing up, right? So this little faceless background application or batch job on the QL no longer has priority, so it doesn't get any time. But I can also set the priority to maximum on the QL is 255, so it's just using a byte. And now if you watch the jobs, you'll see that it's a little slower, right? It's not as instantaneous anymore. And if I go into ICE, you'll see that ICE itself is also a little slower. And if I go, it should still grab the keyboard entries, but it's going to bring that up slower as it's running. And obviously it's not beeping any faster because it's just checking the time intervals a little more often. And so it takes a little longer. But so that's sort of job priorities and how you can play around with it. I want to bring it back to 8, which is what it was before. So basically, the default is it gets about a quarter of the QDOS operating system. But yeah, so this is how I learned about playing with jobs. And the QL is nice because it's such a slow machine that you can really see the impact of changing priorities. And so that's kind of what gave me the idea of CPU doubler on the Macintosh. Let me go now and show you how I did that. Okay, so let's look at RAM doubler first. So imagine this represents space, potential memory that your computer could have. And imagine that each one of these slices represents a megabyte. And so let's say your machine has 2 megabytes of RAM, okay? What RAM doubler did is it divided that in half to 1 megabyte. And then it created a RAM disk out of the other, so you kept 1 megabyte for your programs, and then it took this 1 megabyte and it created a RAM disk. But it used driver level compression to then create a RAM disk at approximately 3 times the size, so which equals 3 megabytes. Okay? And so now you had a 3 megabyte RAM disk, and basically this space expanded because of driver level compression, and you had your 1 megabyte of actual disk space. So then it used virtual memory to use that 3 megabyte of memory as swap space, and therefore you ended up with, kind of virtual memory. What it did is it used that 3 megabytes of memory for your full 4 megabytes to swap out unused portions of code so that you could basically, because it wasn't a true multitasking system, if you had a program running in the foreground, it would use this 1 megabyte, and any programs not running in the foreground would be swapped out into this 3 megabyte section of RAM disk. So basically they were swapped out to disk, and because they were using their code. So that's kind of what virtual memory does. And then if the process needed some time, it could be swapped back into this 1 megabyte section. So the one difference is that I believe that each application could only get a maximum of 1 megabyte of workspace, and that's kind of how the Mac worked. Is it didn't give you indefinite memory for each app. You had to specify how big a chunk can it get, and so an application that was swapped out would be swapped. Its chunk, if it's so, let's say you had 4 applications running at 1 megabyte each. 3 of them could be swapped out. 1 would be here running, and then if another one came to the foreground, it would be the front one would be swapped out, and the other one would be brought into this 1 megabyte of actual memory. And because it was a RAM disk, that swapping would take relatively quickly. And since you're focusing on your front application, then you would see a little bit of degradation, but not much. But you could run 4 1 megabyte applications as opposed to 2 1 megabyte applications. So that's how RAM doubler worked. Okay, and I thought that was ingenious. So they used virtual memory and driver level compression, RAM disk, driver level compression on the RAM disk, and virtual memory to accomplish that. So combination of 3 ingenious technologies. So what did CPU doubler do? Well, so that's messing with space, right? Expanding this space by driver level compression, causing this to go to this size. So with CPU doubler, if you imagine this is a unit of time, so whatever that may be, a second or even smaller unit, but some unit of time that's 1 unit of time that the processor, the CPU on the computer gets. And so there's whatever the clock is, there's cycles that then get sent to the CPU, and the scheduler uses a very simple round robin technique to split these up to various processes. So if you had 2 processes running, it might be that a particular task would be swapped in, and it might grab maybe 6 cycles before it gave the process back away through the get next event, and then the scheduler would then go, okay, the next process, right? So let's say it's 50-50, so that in essence, the first process would use this many, and then the next process would use this many, and etc. But let's even divide it even further. Let's say with 2 processes that each one maybe takes 4 cycles, so that the first process would grab 4 cycles, release it. The next process would grab 4 cycles, release it. The first process would get 4 cycles again, release it. And then the next process, let's squeeze one in here, would take 4 cycles. So that's not really how it works, but it's a good illustration. So the 2 processes, they each kind of work the same amount. When the scheduler gives it to the first process, 4 cycles, they release it. The next gets 4 cycles, they release it. The next 4 cycles, and release it. The next 4. And so let's say you get 16 total cycles in this time unit. So in one time unit, each of the 2 processes got 8 chances at the CPU. That's how fast it would run. Well, what CPU double did is it would actually swap out. So there would be a foreground process, and the other one would be in the background. So if it was in the background, what CPU double would do is, as this foreground process relinquished control and the scheduler was about to give it to the background process, CPU double would say, no, foreground process, keep it. And it would come back, and maybe the second time it would give it to the background process, and then the third time back to the foreground process. So the background process would be diminished in how many accesses the CPU would have, and so instead of getting 8 and 8, now the foreground process might get 12 cycles of this unit of time, and the background process would get 4. Okay, and because it's happening fast enough, if the background process is doing some time-critical stuff like running, network printing or whatnot, it would still be okay, because if it works for 2 processes, well, if you ran 4 processes, the background process would lose that time anyway, and so as long as it wasn't tasked out for a very long time, things would still work, just albeit slower in the background. But the foreground process now has more time, and it has literally 33% more CPU cycles per unit of time to do its job. And that's how CPU double did it. So basically, it compressed the time that background processes got, thus expanding the time that foreground processes got, and therefore very synonymous to how RAM double worked. That's how CPU double did it, and it did it by the task scheduler, basically at the get next event level, when it would keep a list of processes around and their priorities, as I showed you on the QL, similar to the QL's priorities of relative to 32, and make a decision on, oh no, you're in the background and the foreground needs more time, so you're going to be tasked out, okay? And that's what CPU double did. And so it was basically using throughput optimization to give the foreground process the most optimal amount of CPU time to do its best. And so very synonymous to RAM double. So, and it wasn't actually that hard to write that scheduler and give that. And again, the idea came from the QL, and my experience with the QL, because I had worked on Unix. I hadn't that much knowledge of operating systems, but I knew how the QL was able to reduce access to the CPU through priorities. And I thought, well, wouldn't it be neat if the Mac could do it? And I implemented it, and so I had to be very time critical in terms of how do I find each process. So I had to be very efficient. I used a very efficient hash lookup. I remember when I originally was doing this and I was doing a linear search or even a binary search, it actually slowed the computer down, so that my friends called it CPU haver for a while. But eventually we fixed it, I fixed it with some advice from friends. And I created an interesting hash, which actually used the very quickest hash was just to basically filter out all but the last 8 bits of the Mac had a clock of how long it's been open, and so that made a nice hash key that could quickly, just through a mask, be gotten. And that hash allowed me to quickly find I think I had allowed 256 possible or 255 possible jobs that I could quickly find the job and get the information and make a decision on whether they were tasked in or out. So very little overhead to the scheduler, and it worked beautifully. But anyway, so that's how they two compared, and that's why CPW was successful. Again, wish I would call it something different. Wish SoftRAM hadn't been sort of the jerks they were and screwed people, so that there was more trust, because it could have been a much more profound application in the U.S. market. I do have a fond memory of this before I go to the Mac to show you actually how it works, which is I actually ended up doing work at Microsoft for a few years after all this, many years later, a decade later. And I had a colleague who worked there, and we talked about, oh, you created this cool app, wow! And I actually used it back in college. It was in a computer lab somewhere in Pennsylvania, whether it was, I don't know if it was Johns Hopkins or Carnegie Mellon, but it was one of those universities. And I remember I kind of mused as they were saying it, because I was like, oh, that's great. Because I mean, I was the lone company, and I didn't have any resellers in the U.S., and so I know I didn't have an agreement with that university. So likely some student liked it so much that they installed it on all the Macs. But as an individual, I was actually kind of happy with it. I was like, wow, it got more use in the U.S. than I realized. Anyway, CPU doubler, really successful idea and implementation. Successful in the foreign market, especially Japan, because they distributed and resold it. Fortunately, because of SoftRAM, it was never a big seller in the U.S. You can still get it. It's still useful for old Macs, so I highly recommend you download it from. There's a couple of old software sites where you can find it. Where they find old software that is no longer being supported. It's still valuable to run your old Macs fast, so I highly recommend you use it. But that's how it works. So let me show it to you now on the Mac. So I'm on the mini VMac Macintosh. I've configured it to look. If you look at the speed, I'm running it currently at one-time Mac 2 speed. So it's a CPU as a control panel, and this is version 2.0. So this was the latter version. I think it was done in 1997. It's currently running and set to lowest performance. So again, you have a help feature that kind of tells you all the things it can do, how to set it, also how to customize performances, etc. Again, you can deactivate it using key combos. You can exclude faceless background applications like Cron Manager that I talked about last week. The Finder, you can exclude specific files, or you just pick applications that you want here and exclude them. And then the most interesting part here is that you can, so this gives you sort of system performance status, and it's more of a heuristics. I told the distributors that it was going to be really hard to monitor and take statistics while it's running, because it would actually add a lot of overhead. But I did a lot of testing and came up with a set of heuristics that kind of reflected this, certain percentage-wise. So this system has a slider with best performance versus custom performance. So if you go to custom performance, it's where the interesting part happens. You can open this up, and you can see that both the Finder and Cron Manager have a default priority of 16. So it's a little different from 32 and 8 that I showed you on the QL, but it has sort of the similar idea behind it. And Cron Manager doesn't do very much at all, so it's not really slowing the machine down even without CPU doubler running. And the Finder is sort of sitting there as the, you obviously don't want to task this out too much. It's going to slow things down. But so I should also point out that Windows actually also adds priorities to the task manager. You can see that there's a priority column that you can see. You can turn that on through the select columns view. And for instance, if I choose Firefox, I can actually set its priorities to 6 different levels. And so, yeah, and this is Windows 7, but it's also the case in Windows 10. So let me start some applications. I'm going to start Climax. And let me also add Globe to this. So Globe is just a nicely well-behaved background application that runs. You'll see that these run fairly, and what I can do, I want to put this here to run. What I can do is I can maybe write a little test program, right? So let's clear the screen, put the date on there, and then 30 for I equals 1 to maybe like 150. 40 print I semicolon, maybe we add, oops, sorry, 40 print I semicolon, and maybe we add a comma, semicolon, and 50 next I, and then we'll do 60 print, and then 70 date. So if I run this, it's going to look something like this. Yeah, it's going to run, and it's going to take about, I want it to take more than a few seconds so that we can actually see if we get any performance boost. So this is taking about maybe 25 seconds or so. Here we go. So it took 38, yeah, it took like 26 seconds. Okay, that's not bad. It's got two things running now. If we actually go and edit the processes, you'll see that, oh, well, Climax actually is running at a really slow speed. Okay, I was playing around with it earlier. That's really not the default one. So if I actually, again, a foreground process, even with low priority, is not going to be swapped out. It's only the background processes. So it's only when Climax is in the background. But this means that it was giving maximum time to the foreground, to the background process, Globe, and everybody else. So if I give Climax maybe a higher priority, let's say I give it 64, and I give Globe a lower priority, let's say I give it 8 or 4, and I remember these things, okay? So but remembering means that when through next boot ups, it'll come back up. If you just change it, it'll keep it at this current state. So you can see it's already being slowed down a lot. But so now if I rerun this, and again, so having Climax having a priority of 1 didn't slow Climax down as much as it just didn't slow any of the background processes on it much, right? Because it never tests out the foreground process. It just gave equal time. Well, yeah, I guess I can test that as well. I don't remember exactly what I did in this case, but here we go. We've got it now running. So it's 26 seconds, and you can see this is, hopefully this is running a little faster now. So you can definitely see that at 36, we have, so yeah, so we're talking now of 18 seconds. So we gained a lot of time. So it was 26 versus 18. So CPU doubler. And again, let's give it a reasonable one, which I think the default is 32, right? So so if I had given this 32 and kept Globe at 32, and remember those. So that's how it would have happened if Climax and Globe both had the same speed. So let's run this test again. Let's see how much. So you can see it's running. It's giving good amount of. So let's see if this becomes 26, or if giving the foreground process a really low priority actually really screwed things up. I don't think it did. So I think this is probably going to end up at like 5511-ish. I think it's running faster, so maybe not. We'll see. Playing with priorities is interesting, but I've forgotten how it does the relative priorities when the process in the foreground is lower or not. So yeah, no, this was definitely 25, 20. Well, actually, no, this was 25, 28. So this was definitely 26 versus 28. Let's run it again. Because last time with it being 1, it was 26, I thought. But you could be also hitting the boundaries of. So if this is 26, it would be 50. So is it 50, 55, 51, 52? We'll see. But definitely at the higher priority, it did a much better job. Again, these are all relative priorities. And yeah, so this is 20, so 20, so 29. So yeah, so this is, okay, so going back here and editing the processes and giving So now I'm going to give climax back to giving it 1, which is what it was initially, unfortunately. I remember that. So now let's see what this runs at. And one more time. And so I was getting 28s and 29s. And I thought I had gotten 26 when this was 1, but let's see, maybe it was 36. I'd have to look back, but I thought it was 26. But let's see what this gives us. With so the foreground process has a really low priority, and so so this was 28. So it's about the same, 28, 29, yeah. So again, I didn't think that it actually slowed the process down when it had, because these are all relative priorities. But obviously, if I give this maximum foreground, but let's do something reasonable. Let's say, yeah, we want this to have twice as much, and we want really, let's change this to 16 so that it actually gets, you know, as much as everybody else, but not as much as the background processes, since I wanted to run the background. And let's see what this does, and run that. I don't expect it to be 19 like I got when I had it, when I was really switching it back, but hopefully it's faster than 29. It definitely seems like it's moving along a little faster than 29, but let's see where we end up. 25, so yeah, slightly faster, right? So you can see these priorities sort of change. Now let's see what the system status tells us. And again, what system status tells you is assuming that each process could be in the foreground. What is the relative improvement? Because these aren't necessarily splitting up their time as much. So if I change the globe to something silly like, well, let's actually leave the globe alone, and let's change climax to something like 128. Let's give it a lot of priority in the foreground. So remember, I think it could be that is 128. I think it might. Yeah, it's 64. I think is the highest you can get. So I maxed these out at 64. Not 128. So the QL is 255, but I decided to max these out at 64. I didn't want, because I was selling this, I didn't want this to cause carnage, and so I wanted to be careful. But let's see what this does, right? So remember this. First of all, what the, yeah, so it gives you a little bit better relative improvement of 18%. But let's see how this manages now with 4 times as much. Yeah, it's quite, so basically the globe has slightly more than the background processes, but climax has way more than that. So let's see if it goes 9. So it was 19 at the fastest, and let's see where we are now. Yeah, back to the fastest at 19. So that's not a bad range. And if I actually move this up all the way to the front, to the top, I can also get system status, and so that says this gives even better improvement. So let's see how this does. So this should give maximum improvement with the things running, and see if we get better than 19. Again, it seems to always be speeding in the first few and then kind of gets slugging along halfway through, but let's see when this quits. Yeah, let's see if we can get better than 19, which means it would have to be, it's definitely still 19. So it seems like 19 is as fast as it can run. As I said, the heuristics are a little dodgy, but as I said, you have definitely you can see improvements, and this is what CPU did. It basically did try to do process throughput optimization by giving the foreground process more time slices than the background ones, and tried to sort of manage that. Yeah, it was very successful in the Japanese market. I think it was top 3 bestseller in '97. This version 2. People really liked the fact that it gave you sort of an estimate of how much faster it was. Again, it was the heuristics. And it all came about because I didn't have a Unix system at home. This is in the early '90s, but I had the QL, which had a Unix-like, you know, there's a whole set of papers that were written by the designers of the QL's operating system, and they really talked about creating a workable Unix. And because this was an underpowered machine, you really got to see how process priorities worked, and so I really learned a lot from that, and that's how I got the idea for CPU doubler. And I hope you know, it's really nice that there's a resurgence of old 80s and 90s Macs. This software is publicly available. I mean, it was just collected by somebody. I didn't put it out there, but I'm not here to make any more money off of CPU doubler to put on old machines. I think it's out there. You can download it. I had sort of ignored it for the last 20 years, but I'm happy if people want to use it, and you can get it. There's a couple of, I forget what they're called, sites are called, but you can find abandoned software, and email comment in this video if you have questions about it. But CPU, it gives you a little bit of a task scheduling on the Mac OS that you didn't have before, in the hopes of helping you optimize it. So I hope you enjoyed this video. Again, my participant Macintosh. I'll have one more for the last weekend in March, and I'm going to talk about a couple of ideas, and one shareware or freeware that I put out, and another idea of another one that I sort of was doing after 97 when I was kind of done with the company, but I was still interested in creating some stuff, and I decided to put it out there for free. So there are a couple of smaller apps that weren't really ever sold. I had fun doing. I'm having fun doing Macintosh, so hope you appreciate this video, and also being able to finally connect the Sinclair QL to these products on the Macintosh, and how it did have an impact. This little unsuccessful machine from England had some really cool things in it, and that really helped me create this. Now, had I grown up with an Amiga, I probably would have had the same ideas, but an Amiga was not as underpowered as the QL, so I think I learned more from an underpowered machine of the QL. In any case, I'll end here. Thanks for watching, and stay safe, and I'll see you soon.